Okay, so our next section starts with the logs. So logarithms are going to be another way we are able to find a missing value. So we're going to be switching back and forth from log form to our exponential form. So we start with log base b of a is equal to x. And then we'll be able to get to that exponential form that we're more familiar with. So we'll start in this sort of a move and go here, and then we're also going to learn how to go back. So the idea of going from a log to exponential form, you're going to loop. So we're going to go big loop starting from the base of our log. So the base of our log is always going to be like a little number down here. And if there is no base, no little number down there, it's log base 10. So we start at b, then we'll go to x, and then to a. So log base b of a is equal to x, and that translates to that exponential form because we go b to the x is equal to a. And then going backwards, we still loop. The base of our exponent will be the base of our log, and we loop and go log base b of a is equal to x. So we're still kind of looping and always counterclockwise from the base. So we're going to do some examples for that to actually make sense. So we're going to write something from log form, from exponential to log form. So we're kind of in this b to the x equals a form, and we loop. So I go the base all the way to 2. So it's log base 10 of 100 is equal to 2. So I'm looping. So I start at the base for b and loop. So it's log base 3, so 3 is the little number down here, 81, because that's the second number I hit when I loop, is equal to 4. So all we're doing right now is going from exponential to log form, being able to rewrite it. That's going to be part of your homework. Same thing for the next one. We're looping counterclockwise, so it starts with 6. That means that's going to be the base. Then it starts with 216, and then 3 is our last one. So it's log base 6, 216 is equal to 3. And then our last one, even if we have fractions, anything like that, we'll go whoop and we'll loop. So if we want to log, we loop. So it's log, and we start with the base, so that means 1/4 is the base of 16 is equal to -2. And that's just going from exponential to our log form. Next, we're going to evaluating a log. So we start in log form, and we're going to try and figure out what the value is. The first thing we're going to do is set it equal to x. It's going to be our unknown here. That's what we're trying to find. We're trying to figure out log base 8 of 32. What is that equal to? That's x. Our first step is going to set it equal to x, and then our next step, we're going to loop to get into something more familiar, our exponential form. So when I loop, I start with the base. So before it was the base of the exponent, now it's the base of the log. So I go loop. And so it goes 8 to the x power is equal to 32. So now this is a little bit more familiar. It's kind of like what we did in the last section. I've got 2 numbers that I could write to a power of 2, and that's 2 to the 5th. And now I'm solving for x by comparing my exponents. So I've got 3x is equal to 5, x is equal to 5/3. So the idea is you're trying to get out of log form So you loop after setting it equal to x. So we'll do that for this one, set it equal to x, and we are gonna loop. So 5 is what I start with, because that's the base. So 5 to the x is equal to 125. We've seen that a lot. I can write 125 as 5 to a power, so that's what I'm gonna do. I get 5 to the third power, which means x is equal to 3. And then we'll go to our last one here with c. So we're going set it equal to x, it's unknown, and then we loop. So 4 is the base. I start at 4 and I'm looping. So it's 4 to the x is equal to 32. So 32 is popping up again. And so we'll get 2 to the second power, so 2 to the 2x, and 2 to the fifth. So now it's 2x is equal to 5, and x is equal to 5 halves.